Hi, I am Tatsuya Ishigaki. In this short presentation, I present our paper entitled Query Biased Neural Abstractive Summarization using Copying Mechanisms. This research was conducted as a part of a joint research project between Tokyo Institute of Technology and National Taiwan University. In this research, we focus on the task of query-biased summarization, especially with an abstractive setting. In this setting, the system takes a query in addition to a source document, and then the system generates a query-biased abstractive summary. For example, this source document explains about the difference between natural death and euthanasia. And the query is a question about the comparison between them. In this case, the system summarizes the source document by including the mention on comparison between natural death and euthanasia. We focus on abstractive summarization, rather extractive summarization. So in this research, the system is allowed to paraphrase or generate new phrases. First, I summarize related work proposed until 2016. For the last decades, many approaches have been proposed, and they are basically intended to be used for generating snippets shown on the results page of search engines. Many different task settings exist, but we especially focus on single document summarization setting, which is the most basic. On the other hand, multi-document summarization also exists. Most approaches until 2016 are extractive, and they often use the word overlaps between the source and the query as important cues to score sentences. Please note that important words to be included in the summary often appear both in the query and the source document. After 2016, a neural network-based summarizers enabled us to generate more fluent abstractive summaries, but they do not take into account the word overlaps. So in this research, we propose a summarizer that more includes the overlapping words between the source document and query in the summary. To achieve this, we extend a copy mechanism to include more overlapping words. In this slide, we introduce some key points of our model, so please refer to our paper for the detailed formulation of our model. Our model uses an encoder-decoder architecture, so the architecture can be divided into two parts. The first part is the encoder, and the second part is decoder with attention and copy mechanism. We use two encoders. One is for query, and another is for source document. And the encoded information is then passed to the decoder part. The decoder first calculates a probability distribution over a predefined dictionary. And also, decoder calculates the attention weights over the words in the source document. When we calculate the attention weights, we use the information from the encoded query and the hidden state of current decoder LSTM. So we can obtain a query biased attention weights here. And then our overlap-aware copying mechanism gains the attention weights of the overlapping words, and we obtain the modified attention weights here. And finally, we merge the distribution for words in the predefined dictionary and the modified attention weights. So overall, this model gives higher probability for the overlapping words. So these words are more likely included in the summary. We conducted an automatic evaluation by using Rouge scores and also a human evaluation in terms of readability and responsiveness. We compared several variants of neural network-based models with our models, and we observed a statistically significant improvement over the baseline models with copy mechanism. In conclusion, in this paper, we proposed an extended copy mechanism to include more overlapping words between the source document and the query. We observed significant improvements over the basic copy mechanism. Thank you for watching this video. If you have any questions, feel free to come to our Slack. Thank you very much.